This is Module 1, Lesson 9. We're going to talk about multiplying and dividing numbers in scientific notation. And then we're going to do some comparison here. We're going to decide which one is greater than the other and how much greater. Okay? Now, and mainly on how many times greater is what we're really talking about here. How many times greater? First off, let's go back and look at something that we already did in our last lesson, and that's called LARS. I want to make sure we have looked at that again. LARS is a very important part of what we're going to deal with here on on changing numbers to scientific notation, and we're going to really need what we've got here. So I'm going to put this in red so we can see it really well. We're going to talk about the term LARS, and I've got it right here, L-A-R-S. L-A-R-S. L stands for left. A stands for add. R stands for right. S stands for subtract. Okay. So up here, we played with some of these. And to convert this into scientific notation, see how we need to have either one or a number that is either greater than or equal to 1 and less than 10 to go here. We don't. So we need to move this decimal one place, right? To make it 6.7 times 10 to the... Now, this is where it gets confusing. How do we decide what we should be doing here? Are we adding 1 or subtracting 1 from this exponent here when we move the decimal? LARS tells us that. LARS helps us find that. I move this decimal one place right. Right tells me to subtract, okay? So I've moved it one place. I need to subtract 1 from the exponent that is there. 4 minus 1 would give me 3. That gives 6.7 times 10 to the third, okay? So in this case, we moved right, so we subtracted. If you move the decimal right, subtract from the exponent. How about if you move the decimal left? Okay, let's look at this one. We are going to be moving the decimal, well, this one we're going to move the decimal right. Okay, we move the decimal right there. Let's go up 1. Let's find one where we're moving the decimal left. How about this one? Our decimal's understood to be here. We need to move it 2 places to the left, right, to get 8.21, because of its scientific notation, this first digit is going to be either greater than or equal to 1 and less than 10. 8.21 times 10 to the, okay, now we need to know what we do to this 3. I've moved the decimal 2 places left. If I move left, I add. So I'm going to add 2 to that. Correct? 8.21 times 10 to the 5th. 3 plus 2 is 5. LARS is used to let us to decide whether we're adding to or subtracting from the exponent when we're moving the decimal. Okay, we're going to need that while we're multiplying and dividing, because sometimes it's not going to be expressed in scientific notation when we get our answer. Okay? So keep going back to your LARS thing. This is important to you. Let's look at this first one. When we multiply and divide numbers in scientific notation, we are multiplying this number in scientific notation, 4 times 10 to the third times 6 times 10 to the fourth. Okay. If you multiply, use the product rule with the exponents. If you divide, use the quotient rule. Use LARS to adjust the decimal if needed. Okay. To make sure it's in scientific notation form. What I do when I'm multiplying 2 things that are in scientific notation is I'm going to collect my terms. Let's collect these numbers that are in the front. 4 times 6. Notice whenever I am multiplying, I can use the commutative property of multiplication, which means I can move these things around. 4 times 6, okay, and let's multiply that by 10 to the third times 10 to the fourth. Notice how I've collected my exponents, my 10s with the exponents, and I've collected just my terms. 4 times 6 is 24. Notice I am multiplying 2 bases that are the same. Both of these bases are 10. If I multiply two bases, think of it this way. We've done this before. 10 to the third times 10 to the fourth. When I multiplied bases that were the same, what did I do to the exponents? I added the exponents. That's right. So this would give me 10 to the 3 plus 4, or 10 to the 7. I can replace this with 10 to the 7. I've got 24 times 10 to the 7. Now I've got my answer, but is it in scientific notation? No, because the decimal is understood to be here. 24 is greater than 10. So I need to move that decimal one place this way, don't I? I need it to say 2.4. Now, yet let's use LARS to help us decide what we need to do to our exponent of 7. I am moving one place to the left. Left says I add, so I add 1 to the 7, and I get 8. 2.4 times 10 to the 8th power. Okay? Now, let's try one on the next page, number 15. This one has got decimals in it, and this one has got, it's got exponents that are negative. So let's try this. Remember, we're going to collect our like terms. We're going to do 9.5 times 1.4. And then we're going to collect our bases. 10 to the negative 2 times 10 to the negative 3, right? Okay. 9.5 times 1.4. Let's put this over. 9.5 times 1.4. 5 times 4 is 20. Carry your 2. 9 times 4 is 36, 37, 38. Okay. Bring down your 1 because we're going to be moving over. 1 times 5 is 5. 1 times 9 is 9. Now let's add these. 8 and 5 is 13. Carry your 1. That's 13. I have 2 decimal places here, so I move this 2. This is 13.3. That makes sense. About 9 times 1, 9.5 times about 1 would give you something a little bigger than 3, right? A little bigger than that. So about 13.3. Okay. So I've got 13.3 to replace here, or 30. You could use it either way. What do I do when I am multiplying these? If I'm multiplying 10 to the negative second times 10 to the negative third, I look at my exponents. I have the same basis. And when I multiply, I add the exponents. That would give me 10 to the negative 2 plus negative 3. That is 10 to the negative 5. Okay, this is 10 to the negative 5. All right, now, is this in scientific notation? No, because 13 is bigger than 10. So we need to move our decimal one place this way, don't we? This would give me 1.33 times 10 to the, okay, let's see what to do to our exponent, our negative 5 here. Oops. See what we're going to do with our exponent. We have moved this one place which way? One place left. LARS tells us if we go left, we add. So if I have negative 5 down here, that means I need to add 1 to it. Negative 5 plus 1 is negative 4. So my answer up here is 1.33 times 10 to the negative 4. Okay? Now let's look at number 17. This one is a division problem. 3 times 10 to the 7th. Oops, I'm having a hard time seeing my pen. Okay, let me bring it down some. 3 times 10 to the 7th divided by 4 times 10 to the 5th. Okay, let's separate these out. This gives me 3 over 4 times 10 to the 7th divided by 10 to the 5th. 3 over 4. If you divide 3 by 4, I'm going to do my math over here. Divide 3 by 4. How many times will 4 go into 3? Well, it won't go into it a whole time here. I've got to put a decimal, decimal and a 0. How many times will 4 go into 30? 7 times. 7 times 4 is 28. We subtract 28, and we get 2 here. Okay, how many times will 4 go into 50 at 20? 5 times. I have 0.75. In place of the 3/4, let's put in 0.75. 0.75, I've substituted that in place of 3/4. Times, whenever I am dividing, I subtract my exponents. 10 to the 7th, oops, come over here some. 10 to the 7th divided by 10 to the 5th is the same as 10 to the 7 minus 5, which is 10 to the 2nd. So let's put 10 to the 2nd in here. 10 to the 2nd. Is that in scientific notation? No. I'm going to need to move my 0.7, that point here, one place to make this 7.5. Okay, now let's go look and see. If I'm moving right, Lars tells me I should subtract 1. I have 2 here, 2 minus 1 would give me times 10 to the 1st. And frankly, 10 to the 1st is just 10. So you would have 7.5 times 10 to the 1. If I'm doing it's just times 10, that would give you 75. Okay. See if we can see 19. Trying to find my, there we go. Let's look at 19. Let's split these up. I have 9 divided by 1.2 times 10 to the negative 6, oops, divided by 10 to the 2nd. 9 divided by 1.2. Now let's work on that over here. 9 divided by 1.2. I'm going to put, oops, down here maybe. 9 divided by 1.2. I'm going to put a decimal here. How many times will 1.2 go into 9? Well, let's check it and see. Let's see. About 7 times. Let's try that. Oops. About 7 point. Okay. 1.2 times 7. 7 times 2 is 14. Carry your 1. 7, that's 8. 84. That gives me 6. 1.2 will go into 6 about 5 times. Let's try that. Oops. Okay, I'm having a hard time seeing where my thing is. 1.2 times 5. 5 times 2 is 10. It's going to be 7.5, okay? So we would replace the 9 divided by 1.2 with 7.5. Let's see if we can get this back so we can see it a little better. (7.5) times, and I got 10 to the 6, negative 6 divided by 10 to the 2nd. That's negative 2. That's negative 6. That would give us negative 6 minus 2. That's the same as saying negative 6 plus negative 2, which gives me negative 8. So that's times 10 to the negative 8. Okay? All right. Now let's look at one of these word problems. Look at number 23. Told you we're going to talk about how many times greater something was. When you're talking how many times greater, you are dividing. Think about this. If I have 2 guys, I have one guy who is really heavy set, okay? He weighs 200 pounds. I have another guy who is really skinny. okay? He weighs 100 pounds. I decide how many times greater the big guy is than the small guy. I would divide their weights. The big guy is 200 pounds. The small guy is 100 pounds. If I divide those two, I get 2. That means the big guy is 2 times larger, okay? So let's do that here. The mass of Earth is 5.97 times 10 to the 24th. Okay, so Earth, let's see if I can get this on here. Earth is 5.97 times 10 to the 24th. Jupiter is 1.9 times 10 to the 27 kilograms. Approximately how many times greater is the mass of Jupiter compared to Earth? So we put Jupiter on the top, just like we did over here. We put the big guy's weight on the top. We're going to put Jupiter on the top here. Let me get this so we can find it. Okay. So let's try Jupiter on the top. Jupiter is 1.9 times 10 to the 27. Oops. Let's erase that. Jupiter is 1.9 times 10 to the 27th. We divide that by the Earth, 5.97 times 10 to the 24th, okay? Now, in this one, they're just wanting an approximate, so we are going to round some numbers here. 1.9 is about 2. 2 times 10 to the 27th. Divide that by, and 5.97 is about 6, okay? So we're going to say 6 times 10 to the 24th. What we've got is, if you look at this, you've got 2 over 6, let's separate them, times 10 to the 27th over 10 to the 24th. 2 divided by 6. If you divide 2 by 6, you're going to get 0.333, okay? So we're going to put it as 0.33 because we're doing approximations, times 10 to the, and I would subtract these. 27 minus 24 is third. Now, is that in scientific notation? No, we need to move this decimal one place, don't we? So it would be 3.3 times 10 to the, and we moved it one place right. Large tells us if we move right, we subtract. 3 minus 2, minus 1, because we went one place. 3 minus 1 would give us 2. Three minus 1 gives us 2. So we are at 3.3 times 10 to the second. If you move that 2 places, you were talking about 330 times bigger. Okay? Oops. All right. Let's see, that covers, I think I got one more I want to look at, and that's on another page, your next page. And I apologize for the pen being a pain right now. Let's see. Oh no, we're in good shape. That's all I wanted to look at. That covers everything that I wanted to do on this one with you. You've got some homework problems that you can work on. Just make sure you put everything in scientific notation once you finish the multiplication or division.